All right, so that was it for the modern aircraft presentation. Ready? All right, so my name is Kip Lankanaugh. I'm from Kip Aero. We have a booth over here, and I've been a historian all my life, specialist in World War I. We assemble World War I airplanes and make kits and such, so this is kind of like a passion for me. So if you have any questions, don't hesitate to raise your hand anytime during the presentation. If you want some more details, I'd be happy to expand until we run out of time. So one of the key things about early aircraft is if you're going to fly or build an early aircraft, you kind of have to understand the process of how and why. So just having a set of blueprints or a set of photos or drawings is not really, it's only part of the picture. And if you actually have the drawings, you won't understand why they don't kind of work. So that's part of the process we'll be talking about. So the key about early aircraft, most people really don't realize that they were commonly called machines or kites. If you see one or you sit in one, you will understand why. They are very lightly built, mostly because the power available was very little. So they were trying to get the most lift out of what was available. Early aircraft especially, we get used to, we've heard of aircraft spruce for many years, so we think all wooden airplanes are built out of spruce. Well, at the early days of aviation, probably the most common material was bamboo. Now, if you have any experience building with bamboo, you know that if you stretch it or twist it slightly, it likes to snap and crack. So many early aircraft built with bamboo would frequently be wrapped with steel or copper wire between the knuckles to try to make it stronger. Also, we're kind of used to thinking that everything was covered with, everybody thinks it's covered with linen or Irish linen or cotton. Early aircraft were frequently covered with silk and other materials, and early aircraft especially did not use anything for tautening, dope or such. And so you frequently just looked like an aircraft flying around with baggy underwear or baggy pajamas. So at the beginning of the war, the only real perceived mission for early aircraft was as observation type, so they could see where the enemy was. Because at the beginning of the First World War, or what we called at the time the Great War, the primary means of understanding where the enemy was the cavalry. All right, so the cavalry was the eyes and the ears of the army, and cavalry was widely used at the beginning of the war. The concept was an airplane could fly above and spot what the cavalry used to do. They also used balloons, but we're not going into balloons yet. That's for a later talk. So everybody's heard of the Blériot 11. That was the same plane that Louis Blériot flew across the English Channel in 1909. So by the time the war rolls out, it was a very successful aircraft, but it was a very dated design. But it was very typical of the period. Blériots, the early Blériots were made mostly of bamboo. They were very fragile. The early engines were 28 to 30 horsepower. By the time the war rolls around, we have bamboo that's held together and trying to fly behind an engine of 70 to 100 horsepower. Unfortunately, Blériots were so successful in sales, he actually had a factory assembling aircraft. So when the war started, that was one of the few places you could order aircraft from stock. The downside was it was a very inferior and dated design, not much updates having happened in the last 4 or 5 years. So when you refer to early aircraft as kites, you can see many of them look like box kites, and that's in fact what many of them were. That's a Farman 3. The Bristol box kite looks very similar. So you remember you're looking at airplanes, they're just at the early age of doping and such. Lots of thin wires, lots of bamboo, sometimes steel. Sometimes we see things, for example, like spruce or ash. A relatively modern airplane of the period was the BE-2 biplane, which was designed by Jeffrey de Havilland. So it looks pretty modern, a tractor monoplane compared to those pushers and such. An interesting thing about the BE-2 is the BE-2 stands for Blériot Experimental. At the time, the British Army didn't have funds to buy new airplanes, but they had funds to repair the old airplanes. So the old airplanes, they would use construction funds, rename it. We would just, instead of, we repaired the Blériot, now it's the Blériot Experimental 2. Another common type of the early war was called the Rumpler Taube. Taubes were actually manufactured by many different manufacturers, and is called the Taube for obvious reasons. Taube is German for dove. French built Taubes, Germans built Taubes. There are a lot of manufacturers that built Taubes. They weren't all the same, but they all looked like doves. They thought if it looked like a dove, it must fly, so they were successful. One of the most advanced planes of the early period was actually an Eindecker. Eindecker, of course, is German for single wing, one deck. This is a later one. It actually has a machine gun fitted to it. Early aircraft had none. One of the most common features of the early aircraft is the use of wing warping as opposed to ailerons for controls. Frequently, you'll also see completely flying control surfaces. If you look at an Eindecker, there is no vertical stabilizer in front of the rudder is fully flying. So if you fly behind an aircraft with a completely flying rudder, you quickly find out that you always have your feet on the rudder pedals because they're going back and forth. Later on, as the demand for aircraft increased, airplane construction becomes more standardized. Those Farmans, those Blériots, and those other types are built in very small quantities. As the need for more aviation increases, they need more airplanes, and so they start buying in quantities, and everybody has to standardize. Bamboo is not a good material. They start finding other ways to standardize materials, but everybody standardizes differently. So if you look at Blériot or a Newport or a Sopwith, they are completely different aircraft they might be wood and wire, but they are not actually even similar. It doesn't take long before inferior designs from manufacturers are directed to build a successful design from some other manufacturer. So, if you've never seen how an early aircraft was designed, it kind of goes like this. The Army says, we need a two-seat aircraft that goes about 5,000 feet and 80 or so miles per hour. So at this time, drawing offices are very small. Matter of fact, sometimes a drawing office would be Louis Blériot or Tommy Sopwith, maybe with the help of one or two individuals. Sometimes those individuals would have drafting abilities, some that they did not. So the designer of the time, we'll call him a designer rather than an aircraft engineer, would come out of his office, walk out to the hangar floor, and he'd take a piece of chalk, and he would draw on the floor, and he would say, I need a plane that's about 28 feet long, and I want it to be a biplane about 30 feet wide, and you need to stagger the front wing. Or maybe we won't stagger the front wing. So he goes back to his office, and the workers in the hangar go and start to assemble his concept. He comes out a few hours later and says, no, I want the pilot behind the observer. So he thinks a little bit longer, and then he decides, no, I want to put a radial or a rotary engine instead of an inline engine. So this process goes on until somewhere during the stage, the aircraft is relatively complete. When the aircraft is complete, the test pilot goes out, who is frequently the owner of the company, and flies the airplane around for a while and tells them all the adjustments that need to be made. Sometimes the test pilot is actually the guy that did the design. So they fly that plane around, they fly that plane around, they fly that plane around, and they make adjustments. When they think that plane is finally serviceable to see if the Army will buy it, they call the Army and they say, we have this airplane we would like you to look at that we think meets your 3-sentence specification. So the Army flies a plane around for a while, or the Navy flies the plane. They say, we like this plane, we will buy it, we're ready, we'll purchase the drawings from you. We didn't make any drawings. So at that point, we have to have a drawing office. So the guy that originally designed the plane, now that the plane is completely assembled and covered in fabric, has to come up with a set of drawings before they get paid for the airplane. So in his rush to get paid, they do a kind of a shoddy job on these initial drawings especially. So they have a lot of mistakes in them, should we say. The other thing is that the person doing the drawing on the airplane knows, there's a good chance the Army might send that airplane to someone else and ask them if they can build it cheaper. So he doesn't really care how accurate that drawing is, he just wants to get paid. So when you see early aircraft drawings and you see the number of mistakes involved, you have to realize there's reasons for those mistakes. So before long, you start to see subcontractors and drawing offices because early aircraft manufacturers had very few draftsmen. At that time, drawings were not standardized. So they needed to do drawings in order to get paid. They would go all over the country and try to hire draftsmen. At that time, they didn't have 3-view drawings like we're used to. So if the draftsman came from a shipbuilding company, it might look like Harland and Wolff did the drawing. The person doing the drawing next to him might have come from a home building or an architectural or a civil engineering company, and he draws differently. So a lot of your early drawings might look different. So 3 or 4 drawings, people might be drawing on the same aircraft at the time. It wasn't long before they started going from individual to a batch production technique. So if anyone has done hand-built aircraft or hand-built parts or batch productions, they realize that means not quality workmanship, but that just means there's a lot of inconsistency. So some of your early types to reach what we will call batch production techniques of the later wars, Newport 11. So Newport 11 has a rotary engine, but it's what we technically think of as a well-proven design because Newport had been building planes by this period for a little bit. One thing you have to watch about Newports, as a general rule, Newports have, some planes are structurally safer than others, shall we say. So in the case of Newports, when they started making their types of fittings for fuselage and wing fittings, as the planes got bigger during the war, they used pretty much the same fitting design. So as the aircraft got faster and heavier, they were using fittings and such that were designed for much slower and lighter aircraft. You can imagine where that led. All right, so SPAD is actually Société pour Avions Duperdissens. So anybody who remembers the Duperdissens of the pre-war times, this is what it became. It became SPADs. So SPADs are a very popular type. They're fitted with inline engines. Actually, this is Hispano V8s is fitted to most of your SPADs of one type or another. Very strong structural aircraft, but because it's so well built that it has a relatively lower service ceiling. Another of your earlier types that reached production status was a Sopwith pup. Now at this time, many of your manufacturers didn't release the names that we have come to associate with these aircraft are not what they became known as. Because if anyone knows, the Sopwith pup actually was originally known as the Sopwith Scout. So at the time, Sopwith was producing a larger aircraft, a 2-seater called the Sopwith 1.5 Strutter, and when it got to the front, it was much smaller than the Strutter. So the aviation people on the ground instantly declared that the Sopwith Strutter had had a pup. So everyone's familiar with Fokker DR-1. Of course, this is von Richthofen's plane. It's the one that everybody thinks of when they think of the German aircraft. Big difference is the pup was produced in thousands and thousands of pups. There are roughly 180 or so triplanes made. So we think of it as the iconic German aircraft of the period that was really a very small production lot. More common on the German side was the Albatross Scouts. And what's interesting is here we still have an aircraft that is wood and wire, but they also use a more monocoque structure, so the fuselage construction is much more complicated than what we typically think of as a World War I type or a Great War type. So America's contribution to the war was the Liberty engine, and they chose at the time the de Havilland DH-4 for the fitment. So the Liberty was a replacement for the Rolls-Royce Eagle engine the DH-4 was produced in quantity not only in England but also in the United States. So all of a sudden we're going from airplanes that have 70 to 150 horsepower to something that has 400 horsepower. So the economies of operation are dramatically different from your smaller types to your later types. But there are also some really interesting, less popular aircraft that we don't generally think of that should be considered whenever you're considering building early aircraft. Who does not like flying in a seaplane, flying boat? So Curtiss built a variety of seaplanes before the war. They were very successful, and they were the primary patrol aircraft up through the entire war. De Havilland DH-2, so we saw the DH-4, we saw the BE-2. This is also another Jeffrey de Havilland design. It was actually came out after the Eindecker. So at the time we didn't have synchronizer gear on the Allied side, so our solution was to have a pusher with machine gun firing forward. The construction technique, which you can see here, still has longerons, as we commonly know longerons, vertical and horizontal spreaders, and of course we have structural wires. And these wires have, some companies call them strainers, most of us today call them turnbuckles to tighten the wires. FE-2B was also a very common aircraft of the period, a two-seater which was used for fighting and bombing until very late in the war. As you can see, the gunner sits in front, and he usually also has a gun behind him. So at times if they're being attacked from behind, he stands up just like he is here to fire over the wing with no seatbelt. And you can see what's that, about knee high? Same type of construction. This is just an uncovered, so it's a pusher aircraft. And you can see longerons again, vertical and horizontal spreaders. So now we're going to talk a little bit about Sopwith, and we'll use these as a consistency, but most aircraft manufacturers use similar processes. We're going to stay with one manufacturer so that you can see how it progresses rather than changing back between French and British types. So Brooklands, everyone's familiar with Brooklands. It was a racetrack in England, still is there. They still have these hangars there. The Sopwith hangars are still there. Brooklands at the time before the war was a very common place for people to keep their aircraft. People of means kept their aircraft in those hangars, and they communicated and they shared ideas, and that's how many of the early British aircraft were designed or modified. Before the war, Tommy Sopwith was a successful pilot, entered all sorts of races and competitions, but by the time the war rolled around, he was actually manufacturing small numbers of airplanes. Towards the end of the war, it was a very large operation, growing just much like we see in the Second World War as far as manufacturers. By this time, at Kingston-upon-Thames, they took up about a third of the downtown industrial area. So an essential operation of any early aircraft operation is sawmills for the vast amount of woodwork contained in most aircraft. So we're also if you look at what we think aircraft were made out of the time, we tend to think that we have spruce for longerons, or I mean for the spreaders and the wing ribs, and you think of, what am I trying to say? Ash for the longerons. Well, in reality, they used whatever wood was available. So that was what they preferred, but that was not usually the case. And then particularly in England, since they had been, it's a very well-developed country, industrialized, they had been building ships for such a long period, the supplies of woods of any kind were very inferior. So most of the woods they preferred to get came out of Scandinavia. So Norway and such became a primary source of materials for the British. So from small hangars that were building one or two airplanes at a time, by the time the end of the war rolled around, they looked like massive production facilities. So actually this building that you see here with all these Sopwiths in them is still in use today. And I have a later photo somewhere, not for this presentation, but it shows Harrier production in the exact same building. So again, if you looked at those pusher aircraft, you can see the longerons and the vertical and horizontal spreaders. It's the same thing on the tractor aircraft. Most of your aircraft are actually a structural truss. So you have 4 longerons. It's built like a bridge. All right. After the bridge structure is completed, then they put formers on to give it a rounded shape. Doesn't matter if it's a Sopwith or a Newport or a SPAD, they're all built pretty much the same way until you get to many of the German types. So here's a Dolphin with covering that looks just like the plane that was uncovered in the photo before. So what happened, all these manufacturers could not keep up with the demand for aircraft, so they went to a series of subcontractors. The first thing that the Army did, or the Air Force at the time, in all the various countries, they followed a similar process. They would buy the drawings from the original designer, they would pass them along to another contractor to make new aircraft. The problem is that all the drawings were very inaccurate, so it was very difficult to make a flyable production aircraft. They soon found out that independent contractors producing an aircraft from a set of drawings did not work. It actually progressed to the point where by the middle war years, subcontractors it went from to a subcontractor type process where manufacturers were actually building through Sopwith or through Newport, and Newport or Sopwith would furnish drawings and the sample of an aircraft for the subcontractor to build. And the original design or the original manufacturer would supervise the construction of the subcontractors, and they would get a royalty on every aircraft produced. Another key thing is that the subcontractors would send some of their key employees to work at Sopwith or Newport or SPAD so that they could learn how the aircraft was manufactured. So the irony of most of these things that we think of, whether it's a Sopwith or a SPAD or a Newport, most of those planes were not built by the original works. Sopwith baby float planes were primarily made by Blackburn Aircraft. Sopwith made just a handful. Sopwith had a very large number of subcontractors that did not make components. The subcontractors made entire aircraft. And of course, during the war years, many women especially were involved even at this early date. So everybody's heard that they think early aircraft went from silk and then they're linen or Egyptian cotton. Those were the specifications or the thoughts what people preferred, but that was not necessarily what they were made with. Here you go, you get to see another good example. The truss structure, you can see the 4 longerons, the vertical and horizontal spreaders, and on the top of the fuselage, you can see the formers. The formers are usually plywood with spruce stringers or whatever light wood they had at the time going along the top. So the work was divided up so that there were sections that were making wings, there were sections that were making landing gear, there were sections that were making fuselages. We don't have that luxury today, of course. So this is typical. This is a listing of all the subcontractors that built Sopwith aircraft. As you can see, it's quite a good number. Here's just one example. Sopwith aviation numbers are this line right here. The Sopwith Strutter was probably the most successful two-seater that they manufactured. Sopwith Aviation made 246 Sopwith 1.5 Strutters by itself. French manufacturers made over 4,200 aircraft of the same type. All right. So here's another good one. So if we're looking at Sopwith camels, Sopwith Aviation only made 503 camels. Bolton and Paul made 1,550 camels. So the subcontractors were an essential part of aircraft construction of all manufacturers during the period. There's some really interesting videos that you can watch. There's YouTube videos. I can share these with you. Show some period black and white. There's no talkies back at this period, where you can see the factories actually building aircraft, German aircraft as well. It's kind of interesting. In the US video, everyone's wearing coats, ties, smocks, looks very nice. You go to the Germans, they all look like peasants. They look like slave labor almost, so they're not very happy to be working on aircraft at the time. All right, so the problem with building aircraft today is there's not too many 100-year-old people left around to tell you how they did it. And all we have is these very inaccurate drawings, if you're lucky. So we need to relearn many of the techniques that were used at the time. So here's an example of a Nash longeron, and it's being spliced, and we're wrapping the splice. Now we're talking about making those in just a little bit, but splicing is common, so it wasn't just because they couldn't get wood of the correct length, but was frequently used to help realign the wood grain, or where a bend was involved in the fuselage, or they needed it stronger, because frequently the splice is stronger than the original wood. Today we use the same type of material. Sometimes it's very challenging to get cotton tape like that, and you just have to work on do some searching. So we actually epoxy that into place and then varnish over the top of it. One thing we don't have the luxury of today is we're not building 5,000 airplanes. So if you're looking at longerons or wing cappings, for example, rib cappings, cap strips, they need to be bent because they need to be formed. I don't know too many people that have a steam box in their garage. So what we tend to do is we build a jig. In this case, this is a fuselage jig. And we use these jigs to form our longerons. So we splice our longeron. We actually soak it in a tube of water. We tend to like a PVC pipe. It's about 25 feet, 30 feet long, however you need it. Stand it on end with a longeron in it and fill it up with water. You leave it in there for about a week or 10 days, and all of a sudden you have a longeron that you can move without having to steam it. So since we can't afford to have a permanent jig, that is like they're using in some of the movies and such, our jigs are a little bit lighter built. We can actually bend the longerons so that there's no way you'd be able to bend that ash without having it pliable. The beauty of having our longeron jig is we also use it as a pre-assembly jig. So you can see the vertical spreaders there. So in this case, we actually pre-assemble one side at a time and then put the two sides together after they're assembled, because the longeron jig serves as an assembly jig. Fittings at the time were all made by hand. So you can imagine the number of hours it used to take. If you look at the Sopwith factory records or anyone else's records, the average small aircraft at the time took about 3,000 hours to manufacture, and that was in mass production or batch production. We need to do it a little bit faster than that. That's how many lifetimes? So we actually laser cut our fittings and then bend the fittings. The only downside with laser cutting is all the time is in the programming. So unless you're going to do a lot of them, it's very difficult to do. If you're going to make them by hand, and a lot of people will look at an airplane and they'll see, I see 300 metal fittings. So have you ever made a fitting by hand? How long does it take? You make about 2 fittings a day by hand. The other problem is because the drawings are very inaccurate, you will find that whatever the measurements shown on the set of drawings will be incorrect. So you'll make this fitting exactly shown on the drawing, you'll fold it up, you'll put it on the plane, you'll find out it doesn't work. So we find until that we've done it several times, we make 2 to 3 fittings until we find the configuration that actually was probably the original fitting. So you think you have to make 200 fittings, you actually have to make 600 fittings. So in this case, this is actually a strutter being assembled in the back, and we're welding together a stainless steel fuel tank. Everybody says they didn't use stainless steel back then. Actually, they're wrong. Army fuel tanks at the time were made out of steel. Naval tanks were made out of stainless steel. So if you're looking, this, for example, is the rudder for a strutter. And if you look at any drawings, everybody will see a specification for A and P number 5, A and P number 121. That is the shape of a streamlined tubing. It's no big mystery. A and P stands for Ackles and Pollock. It was a company that made rollers that would form steel tubing. So if you go and you look at, there's a lot of manufacturers of steel tubing because they still make steel tubing for Univar makes steel tubing. There's all sorts of places where you get steel tubing that's preformed to shapes that is very similar to early aircraft. The problem is the early aircraft shapes require bending, and most of those shapes are made out of 4130 moly steel tubing. So if you ever try to bend a preformed shape, you find it very, very difficult, and it will tend to crack when you try to form it. They didn't do it that way when it was originally manufactured. They would take a round piece of tubing and bend it around a frame. In this case, we would bend it around a form or a jig that we've made, and then they run it through the rollers after they have the correct shape. So the streamline profile is actually put on after the shape of the fin or the shape of the part is needed. Here's a typical way of doing wing ribs. Same way as we do longerons. They're soaked in water for about a week, and then we put them in a form. So this is the lower wing cap strip for the lower rib, and that's the cap strip for the upper rib. About 24 hours later, you take it out, it's got a pretty good form. Wing rib is actually one of the easiest things to make. Once you get the form done, you clamp them up, you can crank out several per day without much stress. So these are offset clamps that we use to hold the cap strip to the webbing. Many of your early aircraft at the time, unlike our later wing ribs that you see in this room, they're made out of plywood. We actually do them out of with a wood router, a CNC router, but in the early days they were just all made with a jigsaw. So if you're going to assemble an early aircraft, the first thing you do is do the longerons and the fuselage. We have the 4 longerons, which provide the structure separated by the vertical and horizontal struts. So once you have your bridge built, then you can start hanging on all the rest of the equipment. So if you can see up here, you build your structure, then you can put on the formers, the top formers. You can come back and put in the seat mountings and all such things. But the first needs to start with a truss structure. They all start with a truss structure. So the toughest things to remember is there was no standardization of engineering drawings. An interesting side effect is engineering drawings were actually standardized by the U.S. Army at the time because we couldn't mass produce foreign designs. We would get a set of drawings or a sample of an aircraft or an engine, and we couldn't reproduce an aircraft based on those drawings. So the Army developed what we now know is the Army-Navy standards, and what later became Society of Automotive Engineers, became the standard 3-view drawing and the way we determine thread pitch and counts and how many flats and the shapes and such. That was all determined during the First World War by the United States Army. As a general rule, you will find almost no specifications. If there's any specification, it will be usually written on the drawing. The other thing that's very frustrating is there's no standardization of hardware types. Hardware would vary from subcontractor to subcontractor. On the Sopwith aircraft, for example, we have imperial fittings and we have metric fittings. For example, many of the strainers and bolts are specified in 4, 4.5, 5 millimeter threads. And many of the bolts and other fittings are frequently specified in imperial standard, or what we call American standard. Another thing is that we're all used to hearing, as everyone here has heard, that a Sopwith pup uses an 80 Lerone. Engines were fitted as available at the time, so most aircraft were fitted with a wide variety of engines. Early pups, for example, were designed for an 80 Lerone, but they are also frequently fitted with 100 horsepower gnome engines. In the case of a Sopwith Camel, there were probably about 6 or 7 different engines which were originally fitted to Sopwith Camels. Here is a typical early aircraft drawing, and this actually is by the Sopwith Aviation Company. And you can tell it's one of their later drawings for a Sopwith pup because they actually call it a pup by this time. Sopwith drawings are relatively available because Britain survived the war unscathed, practically. And if you go to Germany, most of the German and French drawings were severely damaged during the Second World War. So drawings for British types tend to have are more available generally than the French and German types or the Austrian types. All right, so here's another pup drawing. There's something that's kind of nice about most of your Sopwith drawings. They tend to have a bill of materials for everything on the page up on the right side. And this drawing is dated, let's see what the date of the drawing. I don't see it, but it's probably dated about 1916, early 1916. But it's all handwritten. The method of drawing varies. Another interesting thing about Sopwith aircraft is the drawing numbers get later. Their nomenclature changes. So at one time they're calling it a appendage. Later on they're calling it a horizontal stabilizer. So the only specifications you'll normally see is written on the drawing or in the bill of materials. Here's another typical one for the main planes, or what we call the wings for a pup. Here's a detail photo of where this is the A&P number 121, where it goes around the edge of the wingtip, and the attachment methods. A little bit better attachment of the view of the bill of materials. So not only do you have to interpret all the handwritten notes, but you have to be able to interpret the way they made F's and S's and all the other varieties of spelling at the time and language. Here's a camel. And if you notice on these early drawings, even the splices are shown. So here in the camel, there's a splice back here towards the tail section. So engine types varied. Some manufacturers documented this very well. Here we'll go to the Camel, for example, and this is from Sopwith's original records. 130 Clerget, 150 Clerget, 140 Clerget, 110 Lerone, 100 Lerone, 150 Gnome, 150 Gnome, 180 Lerone, 150 Bentley. That's only page 1. So when you think that they were all fitted the same, they're the widest variety depends on what was available at the time. Another thing that gets kind of confusing on early aircraft is we frequently see, here's a case of a Sopwith Dolphin. It lists a Hispano-Suiza. So Hissos, we all know what a Hisso is. But we also have Wolseley Viper listed, which is actually a sort of license-built version of the Hispano built by Wolseley with their own improvements. So although it shows a 200 Wolseley engine, a Hispano engine would be a suitable fitment for the same aircraft. So when you look at the characteristics of early aircraft, the key is the construction theory varied dramatically from manufacturer to manufacturer. But there are some similar characteristics. Your early engines all operate at very low RPM with very large propellers. It gives it a unique characteristic. If all we wanted was a lightweight engine with a lot of horsepower, we'd all be flying McCulloch-powered aircraft, right? A little 90 horsepower, it weighs 50 pounds. Most aircraft at the time were relatively safe when operated within their known limitations. Everybody hears the nightmares about the fatality rates and such of early aircraft. That was usually due to lack of training. Most pilots during the mid-war years had an average of about 15, maybe 17 hours of training before they reached the front. Usually that was in at least 2 to 3 different aircraft. By the time they get to the front, they reach their squadron, they're flying an aircraft type they've never flown before. So they've flown 15 hours in 4 different airplanes with different engines on every one, and they don't know how to fly yet. So the reason they're smacking up and getting shot down is because they don't know how to fly yet. So we consider people that have 40 hours to be non-competent pilots, right? But that's usually when you get your pilot's license. So imagine you had 1/3 that amount of time. It did change as the war went on, but that was common. All right, so when you go to choose an airplane to build, there's several things you need to take into consideration. Is don't listen to what everyone else has said. Do your own primary research. All right, so most of the pilot logs, letters home, will tell you their experiences. There's many of the pilots that flew for long periods of time and would accumulate quite a detailed library or letters written home, diaries and such. It's very, very well documented on how different aircraft fly. The early pilots who crashed and died, you only have 2 or 3 letters and you don't know how that worked. They didn't know what they were doing anyways. In the early time of this aircraft, they didn't even know what spins were or what caused spins. So you need to have a pilot that's flown for a little bit before you can describe what it was actually like. So when you're building something, availability of detailed information is very important. It's nice to build a plane that no one else has built yet, but if all you have is 5 drawings, it's going to be tough to build an accurate copy that's safe to fly and has the same handling characteristics. Now for all of those married types, I would especially like to remind you there's something to be said for 2-seaters. No one wants to fly alone. And if you build an airplane that's going to cost you $100,000, your wife is going to have a really nice car or something similar. A lot of people take into account engine availability because the 2 characteristics that you need is low RPM and a certain horsepower range. If you're considering a rotary engine type, rotary engines, new old stock rotary engines, or older engines that need to be restored are available. And that might be the choice. For many years, that's been what was the deciding choice of what airplane would buy or build. People would find a Renault engine or a Clerget engine, and then they would build a plane that fit that engine. Today, there's actually availability of not only older types, but there are new engines, new rotaries available for someone that wants to build a rotary engine. The other thing is to be realistic about the time frame. The more unusual your aircraft, the more research time it's going to take. All right? Most people I know that have successfully built a World War I aircraft take 10 to 20 years to complete the project. Most people never complete their project. So be realistic about your time available and the time it's going to take. There's some really good resources available, so take a picture of this slide. Because if you want to know how they made it back then, every manufacturer made it different. These sources are very good sources on the methodology used by all the different manufacturers because they all have listed how someone spliced it or how someone else did their wing ribs or such. Drawings are readily available for many of your common types. One of the best sources that's readily available is from Replicraft. If you don't know Jim Kiger, he's done quite a few things with Newports, Henriettes, Sopwiths, and other types, SE5s. He has some very economical and good quality drawings available that cost somewhere around $100 a set. But if you want to buy those, buy them soon, because I think Jim is about 87 or 88, something like that now. If you want to build a more unusual type, there are a number of sources. In the UK, the Public Records Office is a very good supply, but you have to go and you have to research it yourself. You need to go to the Public Record Office and request the files. It takes quite a bit of time to find what you're looking for. National Museum of the U.S. Air Force also has some very good availability of drawings. If you know someone that is there, they're not very open for persons that don't have a contact. So if you're really interested in something and you're serious about it, you can contact myself or someone else. We can help you get into some of those drawings. National Naval Aviation Museum, National Naval Air Museum in Pensacola is also a good source, as well as the Smithsonian. A couple of things that are really important when you're building aircraft is rigging notes and engine manuals. Those will never be with the aircraft, but they are required to assemble the aircraft. So those are the essential items you need. So, questions, thoughts? Yes? Right. Most early aircrafts used glues that are rendered. So it's usually an animal glue. So if anyone's looked at, for example, an Elmer's glue bottle, there's Elsie the cow or whatever on there, that's because that's made from animal renderings. Our glues today are much superior to that, and so we tend to have longer lasting glues. Commonly we use two-part epoxies. Actually, your original Gorilla Glue is actually very strong, usually stronger than any of your wing rib materials. It's a good supply. Most of if you're looking in all the epoxies and such are pretty good. When I'm doing wing ribs and stuff, I like to use a Gorilla Glue because it is stronger than the wood in the cap strips, and it doesn't come apart, and it comes in a tube like an Elmer's glue, and so you can put it right down the channel where the wing rib comes together with the cap strip. Another thing you have to remember is the materials of the time were very inconsistent and inferior. For example, if you look on a Sopwith drawing and it refers to the gauge of the steel fittings, it will say 14 gauge mild steel plate. So does anybody know what mild steel plate is? I don't either. There was no specification at the time. So we know that it's not armored steel, it's not high carbon steel. So we defer to 1081, or our most common is what we interpret that. Chrome moly was not commonly used back then. We tried not to overbuild certain portions of it, because if you make one part stronger, it's going to change the failure point in wherever the aircraft is. So you want to make it as close to the original as possible. That way it will have the flying characteristics of the original aircraft as closely as possible. Yes?
Do you know what steel tubing Fokker used in their Fokker triplanes?
All right, that's a good question. So most of our example was of Sopwith, which was using wood. There is quite a bit aluminum also used in cowlings and such, and in Strutter they used the air brake is made out of aluminum. A lot of your German planes used steel tubing. Probably nearly 50% of the aircraft made, like your Fokker D7 and such, use steel tubing in larger aircraft. At that time, there was not very accurate specifications. Normally, if you see a note on any of the early aircraft drawings and it says welded, that usually means brazed. It does not usually mean welded. So, and for the materials at the time, that's probably adequate. We frequently TIG today just because we always have our TIG welder out. We don't usually, we can, but we don't usually braze things together that much anymore. The Fokker tubing, anything that at the time, probably mild steel is the most accurate rendition of the time. German steel was not usually referred to by those types of methods. Krupp steel was generally recognized as being a high carbon armored type steel, but they usually were by name rather than by numbers and codes like we're used to these days. So any of your materials today are generally superior to what they were at the time. Our methods of, actually our wood selections are much, much nicer than they were at the time. We're good? Yeah, go ahead. Yeah. So the downside with most of your German aircraft, everyone wants to build a Fokker DR-1 triplane. Well, there are really no accurate drawings left of the Fokker DR-1 triplane, but there are many period photographs. The other problem is if you want to use an original aircraft as a pattern, if you want to go to the Smithsonian or the Air Force Museum or some other place and get detailed photos and such of their aircraft, you must remember that airplanes probably already been rebuilt 3 or 4 times to various qualities of replica. So just because it looks like that in the museum does not mean that's the way it was made. The quality of our reproduction capability has increased over time. Aircraft that were built, reproductions back or replicas back in the 50s and 60s are nowhere near the standard of many of the aircraft being built today. So, other thoughts? What's that? Being made to last 5 or 6 flights. The key to extended life in an early aircraft is obviously hangared and flying it in good weather conditions. Also in the early props and such, they don't like rough fields, flying in rain or bad weather. They did that at the time. The best thing you can do to preserve the aircraft is keep it hangared and out of the sun as much as possible. You also have to be realistic. There aren't too many people that are going to go out and fly an early aircraft for a 5 or 6 hour mission like they might have done 100 years ago. These days, if you go and fly an aircraft, you're probably going to fly around the patch for 30 minutes to an hour and come back and land again. Even the aircraft might have a range of 4 or 5 hours. Few people actually do it.
Can you comment on how you shape a large piece of plywood or something like an albatross? You have a large section.
All right, so if you're looking on, for example, on like many of the Sopwiths, you'll see where the plywood like is on a pup or a strutter. You'll see the plywood that's right in front and back of the cockpit. That's what you're talking about. Those pieces, most of those are called 4x3 ply plywood. And if you ever get a sheet of plywood, you'll notice that if you go to twist it, it will twist really well in one direction where you can bend in one direction. The other direction, it won't twist much at all. So whatever direction you're twisting, you make sure you cut it with a grain so that you'll have 2 grains going one way and the other grain going counter to you. Makes it much easier. If you're looking at the albatross types and such, those need to be built up of many laminations because it's very difficult to bend plywood. They're usually made up of several very, very thin layers.
Let me ask you a question about that. If I look at a pre-World War II piece of plywood, usually it's made up of about 3 to 4 laminations. Now, the plywood you can buy like 13 laminations of the same thickness. Are you having a problem with doing stuff now that it's more thinner layers of ply, or is it still working?
We don't go with the thicker layers of ply. We stay with the original if it calls for 3 ply of a certain thing. We are usually willing to wait for the plywood to be made. If you're making an aircraft of this era, for example, and you need 400 turnbuckles, I can tell you there's no supplier in the country that's got 400 turnbuckles for your project on the shelf. So they might have in their catalog, and you order 50 of one size turnbuckle, they're going to send you 3, and a year later you're going to get the other 47. And it's the same way with plywood. If you went to aircraft spruce, for example, and you wanted a particular type of plywood, enough to do wing ribs for, say, a Sopwith or a Newport, you needed maybe 20 sheets of plywood. They might only have 2 or 3 sheets in stock. So, and if you got together everyone from each one of their East and West Coast stores, they might come up with 4 sheets and you need 20 sheets. So what's going to happen is they're going to have the supplier make more for you. So all that can be made, it just takes time. So just because someone has it listed online in their catalog or in their printed catalog doesn't mean it's readily available. Another thing that's very common is we all like to think that we need a lot of bolts, whether they're, but most of the fittings we use today and all the bolts we use today for modern aircraft, we're usually bolting together several layers of sheet metal. So most of your bolts that are readily available are all going to be something that's less than 1 inch in length. Most of the bolts and such that we need today in an antique aircraft like this tend to be 1 inch, sometimes 2 or 3 inches long, and very few places stock more than 1 or 2 of those. So although they might have that part number for an NAS 6203-37, 34, 36, the reality is they've never ever had one in stock. They just happen to have it on their list because it fits in their numbering system. So if you need something like that, sometimes you have to wait. So time becomes one of those issues where you plan in advance and work with what materials are available at the time. But the plywoods, you can still get all the plywoods that they specified, and you just have to be patient, and they'll still make it for you. Engine cowlings. That depends on the engine you're making. All right. So World War I types, everybody likes that round engine cowling that looks like that's typical of your rotary engines. They are kind of challenging to make for most people because they're made in 2 different methods. All right, they were made on an English wheel, commonly, or they were spun. There are a place that will do either. So you need to develop a competence for that. If you go to some place to have an engine cowling made, don't tell them it's an engine cowling for an airplane. They won't make it. So what you really want is you want the rough shape. You ask someone to do a spinning for you. Well, if it's not a commonly available cowling, or someone's not already making it, they're going to have to manufacture for example, it's a wooden, what am I trying to say, pattern that the cowling is spun over. So you spin the cowling, and then you have to work it to make the shapes for the riveting holes and cut the access doors and such after you have the base spinning. If you're really good at metalworking, you can do the same thing with an English wheel. It just takes time. You can also do it with a planishing hammer if you're good with a planishing hammer. And you can make it out of small sections and weld it together. My recommendations, everybody's probably competent at doing one or another level of welding. Unless you're extremely talented, I would recommend that you make cowlings and such out of smaller pieces of aluminum and have them welded together by an aircraft competent place somewhere in your vicinity. Welding aluminum is challenging for most people, so unless you do it on a regular basis, you'll have a hard time making a good quality weld that you can planish down and form into a nice looking cowl. But there are still several numbers of places around. Most of your modern jet engines, the cone in the center of the engine around the shaft is actually a spun part.
Are there suppliers that will sell them?
There are a handful of places that will make a cowling from scratch for you. It's very few. But if you look at many of your aircraft types, they're not always a spun piece. You can make it many ways, especially in the subcontract when they were originally made. They were frequently made different ways. So if you went to an original Sopwith pup and you saw 4 different pups made by different subcontractors, all the cowlings would be very different, even though they came from the same drawing. Yes? That's a really good question. All right. Wheels for many of your early aircraft at this time were smooth types, and they look like bicycle wheels. Don't be fooled into using a bicycle wheel on a 1,500-pound aircraft or even a 1,200-pound aircraft. Just because a mountain bike wheel looks appropriate, don't go there. The best and economical source for wheels, depending on the aircraft, is you look in a Model T or Model A supply. and they will usually have rims and tires and such available. The hubs need to be made, but they're very simple to make a wheel hub, and there's a number of places around the country that will actually spoke a wheel rim to the original configuration. One that we've used before is called Buchanan spokes, but just look for anyone that does spoked wheels, and they can do that for you. But if you can buy a rim, for example, you can buy a Model T rim for maybe a couple $100, and then you send it out to one of these spoking places, and they'll dimple it in the right places and spoke it to your hub. Yes?
Are they still making engines, rotary engines in New Zealand?
Yes. Yeah, rotary engines are still made by a number of manufacturers. CAMS in New Zealand makes new rotary engines. They make a Gnome Monosupapi 100 horsepower. The original engines back then the Gnome 100 used to put out about 94 to 96 horsepower. The ones that they're building, just because their tolerances are better and they're using some better materials, their engines are actually putting out 125, 126 horsepower. So for all of us people, just remember the pilots back then weighed about 135 pounds. So we do need a little bit more horsepower to get us off the ground. Yes?
Just curious, why do you discount the value of motorcycles, spoke wheels, small motors?
All right, so that's a good question. Motorcycle wheels, they look very acceptable. The problem is they are much heavier. So I look at it this way. Every time you add 2 ounces, by the time you add 2 ounces 3 times, that means I can't eat breakfast. All right?
Of course, we don't. Difficult to figure out how much strength I need for the airplane wheels, right? And you say they're heavy, but I guess they have to be strong.
Well, if you look at the original drawings on an aircraft wheel, they'll actually give you the diameter of the spokes. So you know if it's a 14 millimeter spoke or whatever it is. They'll give you the size of the wheel, the size of the rim, the size of the spokes, the offsets. Another thing that's kind of interesting on early aircraft is the hubs were not usually bearings. They were usually just a bronze or brass bushing. It's because most of your early aircraft take off in a matter of 100, 200 feet. So they don't have to roll far. So yeah, but a motorcycle wheel today is very, very heavy by comparison.
Well, they're big motorcycles and small ones.
Yes, yes. But the other thing is the wheels are very large for most of your aircraft. Most of the ones that we deal with, you're talking about anywhere from about a 26 to a 30-inch diameter wheel. All right? Oh.
Off the shelf, or do you have to make your own?
All right, there's a number of places. That's a good question. Propellers. Actually, how many people have seen the Hartzell propeller booth over there, right? So everybody knows that Hartzell started out by making furniture. Do you guys know that? And when they decided during the war that there was a demand to make propellers because their furniture business was tapering off, the original name of Hartzell propellers was Hartzell Walnut Propeller Company. So most of the propeller manufacturers, although they don't say it, they actually will make wooden propellers. There's also a number of specialists that make unusual propellers. So I would not recommend running a 100-year-old propeller. But all of the propeller shapes and sizes and dimensions are well known. Most of those guys still have the records for them. All the Sopwith designs are still out there in the different prop sizes. There's a couple places, Jeff, I can't remember his last name, in New Zealand actually makes brand new propellers. There's most of the propeller manufacturers, if you walk around here and you ask them, do you guys still make wooden propellers? And they'll say yes. And they'll make custom propellers. Just be ready to pay though, because most of your propellers for this type of aircraft are usually talking about $7,000 to $10,000 for a propeller. Yes? We're over by the just north, or just east of Hangar B. All right. Thank you very much.